Hi guys, welcome back to yet another episode of DSA Python series. Okay, and let me set the context for today's video. Today's video we will be dealing with deleting the node in a doubly linked list. Okay, so let me share this screen and delete the doubly linked list. Okay, I hope the screen is visible to you and give me some time. So yesterday we saw what a doubly linked list was, right? Okay. So okay. Let me just share the whole window. Okay. Now doubly linked list was, so it has got this none value. So empty doubly linked list will be like you don't have any addresses as such, right? You only have this value. Okay, you only have this value, right? So do we want to do now? Okay, is let's say this is my linked list. Okay. Doubly linked list, right? And so this is the structure of doubly linked list. I would say this is the value. Let's say this is 5. This is 5. This is 9. This is 10. This is 15. Okay. Now here it is none. Here it is, let's say its address. Okay, so let's say this is 788, 793, 814. So this will be 814. So it will point towards this. This will be 793. Okay, and this will be 788. So it will point toward this, right? And 5. This will point toward this. This will point toward this. Let me 5. This is pointing towards here, right? So this is 793, and this will be none. Let's say this is the last node, right? This one is the last, right? HEAD, head. So it will point toward this will point toward this, and 7, this will be 788, right? This will be, let's say, 523, so this will be 523, like so. This is how the node is created. I would uh, mark these nodes as, let's say, this is 0, this is 1, this is 2, and this is 3. However, these numberings doesn't matter for this linked list, doubly linked list, right? Still, if we have to traverse, then what we will do, as like we did yesterday, we will do count, okay, and we will increase the count, and it will iterate, right? Now, what can be the concept behind deletion of the node, right? How do we, what basically we have to do? Let's say I have to delete this node, right? I have to, I need to delete this node. Ready? I need to delete this node. What will I do? What can be the funda? What is my thinking process? Okay. क्या सोच रहा हूँ मैं? Okay. How do I do this? What can be the logic? Okay. So in doubly linked list, what we have to do is we need to like in singly linked list, we only did this. Okay, we only did the, we just did this. Okay, simply we put the address of this node. Okay, what I'll do, I will just do let's say this is current, so I'll just do current dot next is equal to current dot next. That's it. Okay, so current dot next is equal to current dot next, right? So it will assume this node 3 will assume the position of this node 2, right? So in simple singly linked list, what I did, current dot next is equal to current dot next. Okay, this was the basic, I mean, idea which I'm telling you here. But here what we are supposed to do, we have this arrow also, and we have this arrow also. So I have to remove both these arrows, right? And i think i I have to remove this arrow. What about this arrow? This arrow, I don't think it is required, because in singly linked list also we didn't care for this arrow, right? We need to only care for this arrow, because this address I have to change to this address. Okay, this should not be 793, this should be 814, right? So 814, and this 814 I have to no, this is 793, no? Okay, this is correct. So this 793, what I have to do is I have to delete this 793, and I have to so prev should be, what should be my previous? So my previous should be this 788. This should be my previous. Okay, this should be my previous. This should be my previous. Okay, right? So I want this 788. Okay, I want this 788 to be filled here, right? It means that my so what I'll do, I'll take one current and one previous. Okay, and let's say I want to delete this 10 value, right? I want to delete this is 10, and I have been given जो भी val equal 10 होगा, that I have to delete. So it means that once I reach this val, my process should start. Whatever juggling I have to do, my process should start. That is what the idea should be, right? That is my idea. Okay. How to delete a node, right? I'll just so what I'll do is I'll assume a variable which will be my current. Okay, current will be my variable which will be initially my head. Okay, so current will be equal to self dot head. Okay, now what I'll do, I have to traverse this current. Okay, I need to traverse this current in this direction, right? So up to what node it will go? So the current will go up to that node. If current dot val. Okay, so let us understand this question first. Given the head of doubly linked list and integer x, delete the node at x position and return the head of the modifier x position. So x position we it's given the x position. It means that I have been given x equals 3, input x equals 3, so output will be 3, 1, 2, 3. Okay, so uh, this is one based indexing. One based matlab I have to start this not from 0 but from 1. So 1, 2 and 3. So third position is fourth node val equals 4. This is the third position, right? So this I have to delete it because x is given, x equals 3, right? So this I should delete it. Okay. So my answer should come like this. So 4 is not visible here. So it means that this will be my null. And so everything is created already. I have this linked list already created. I just have to traverse till what point? Traverse till position 3. So it means that I have to take a variable, um, and and that variable will is has to be count. Okay, and I will just say the value of count should be less than uh, whatever position I have, this x, right? So while we'll have two components then for traversing. First is um, while current. Okay, so can I just make it little bit small? Okay, so I will say while current. Okay, or will it be or? uh, if I put or, then any one condition. Let us take and. Okay, while current and count less than position. Okay, count should be less than position. Till that point it will traverse. So it will do current is equal to current dot next, right? It will keep traversing. This will be my idea. I mean, mota moti idea, that vague idea I would say. Or as soon as my count position is less than current, should I mean to have this less than current? So I will my count will start from 1 only. So my count is equal to, initially my count will be 1. Okay, and because this head current is equal to self dot head I have done, no, it means that current value is already taken, right? So I will just say current is equal to 1, and then current will go, right? And I will just do count plus equals 1. So if count is less than position, then so I have to create one def function also here. I have to, this is already created, no? So let us write this code. Okay, I have this current is equal to, so I have this current is equal to self. Okay, I will just assume current is equal to self dot head first. Then what I'll do, count I'll say equal to 1, count is equal to 1, and I will do while current, and uh, I will do count less than position, or count less than x, because this x is given, right? This x is given. So I have to maintain this count. Let us assume that I have to maintain this count less than x as of now. Then if there is any mistake, then I'll correct it whether it will be equal to or not, because head of body x position. I have to delete at x position, no. So if I make count equal to x, then after that I'll act. That can also be done. If count is less than or equal to x, that also I can do. But then I have to act when count will be equal to x, then what I'll do, I'll juggle those things, right? I'll, you know, uh, I have to delete this, I have to delete this. Okay, it means that I have to, you know, put a link on the next dot next wale mein. I have to put the link, and when I have to delete this, then is wale ka I have to maintain that one current and one previous also, right? Then only I have to check. So so current, and I have to take the previous also, right? Previous as in self dot prev none. So I'll say current is equal to current dot next. It will keep going again. Okay, let us dry run now. Count plus equals. Let us dry run, then we will understand, right? So let us dry run this. This current is equal to. Okay, so my count is already one when my head is equal to this, right? And now while current and this count is less than position, right? So both are, you know, we are satisfying. Okay, so it will again do current is equal to current dot next. So it will come here, right? uh, okay, then so my uh, my current is here in second iteration, right? So in second iteration, at this point, my current will be, now it is starting from 1, okay, and it is 2, and it is 3, and it is 4, because my indexing has to be 1, right, from 1, right? See, this position starts from 1, right? So 1 based indexing, right? It is given in the question, 1 based indexing. It means that I have to maintain not 0 but 1 based indexing, right? So यहाँ पे मुझे 1 करना पड़ेगा, then 2, then 3, and this will be 4, right? This will be 4. Okay, this is the last node. I want to delete this third number of node, right? So but I have given count, so count 3 पे मेरे को काउंट और मेरा जो x है, x इज इक्वल टू 3 पे मुझे डिलीट करना है भाई, इसको डिलीट करना है। ओके, सो इसको डिलीट डिलीट करने के लिए मुझे यहाँ पहुँचना तो पड़ेगा ना, लाइक मुझे मेंटेन करना पड़ेगा प्रीवियस और करंट दोनों। करंट को मुझे कुछ खेल के, लाइक व्हाट आई हैव टू डू इज, करंट मेरा आगे चलता रहे और प्रीवियस मेरा पीछे पीछे चलता रहे, ऐसा कुछ अगर अरेंजमेंट हो, देन व्हाट व्हाट आई विल डू इज, काउंट भी मेरा रहेगा। So current, now the current is 2, right? My current is at second position. It means that count is equal to 1. My current, so count is 1, so count is less than x. So position is nothing but x, and my x is 3. X is equal to 3. Okay, so here my count is 1. Okay, here 1, first iteration, let us consider. So less than x, yes, current is equal to current dot next. So count plus equals 1 हो गया. So count की वैल्यू हो गई 2. Okay, so count की वैल्यू हो गई मेरी 2. Okay, so current is equal to current dot next भी हो गया. Okay, so current मेरा यहाँ आ गया, right? Okay, now 2 is less than x, yes, because x is 3. You given a question, x is equal to 3. It means that 2 is less than x, so it will go into the loop. लूप में गया, देन अगेन इट डिड करंट इज इक्वल टू करंट डॉट नेक्स्ट। ओके, सो अब मेरा करंट चला गया, अब मेरा करंट चला गया इधर, यहाँ पे आ गया मेरा करंट। ओके, सो करंट यहाँ पे आ गया, करंट इज इक्वल टू करंट। उसके बाद हुआ काउंट प्लस इक्वल्स 1। ओके, काउंट प्लस इक्वल्स 1 मतलब अब ये मेरा हो गया 3, दिस हैज बिकम माय 3। ओके, तो अब वापस इस लूप में आया, देन क्या काउंट 3 इज लेस देन 3 है? क्या काउंट 3 लेस देन 3 है? नहीं, लेस देन 3 नहीं है, लूप विल स्टॉप। तो मैं एल्स में क्या लिखूंगा, what I'll write in else, or in the next, even if I don't have to write this, where is eraser, eraser कहाँ है, 0। okay, so 7। okay, यहाँ पर सिंपली मैं while के बाद, while के आउट ऑफ लूप में मैं यहाँ पे कुछ कंडीशंस लिखूंगा, राइट। I'll write some conditions so that ये जगलिंग हो जाए, जगलिंग एज इन इसका एड्रेस उधर चेंज हो जाए, उसका एड्रेस इधर हो जाए, बैक वाला सही चला जाए, ये सब चला जाए। बट व्हाट इज हैपनिंग विथ माई प्रीवियस, वेयर इज माई प्रीवियस, आई डोंट नो येट। मैं तो केवल करंट कर रहा हूँ, एंड करंट के लिए देन if I have only one current variable, then I can delete only one set of direction, right? When I have to remove the other direction, then I think I need one more variable, previous को भी मुझे आगे चलाना पड़ेगा। So let us write this rough code, then we can सो ये यहाँ पे तो आ गया। ओके, करंट की वैल्यू मेरी 3 हो गई। ओके, एंड 3 लेस देन x है, नहीं है, इट मीन्स दैट मेरा करंट यहाँ पे आ गया। तो अब मैं क्या करूँ, इसको कैसे डिलीट करूँ? सो व्हाट आई डू इज माई करंट डॉट नेक्स्ट, मतलब ये वाला, आई थिंक मुझे मेरा यहीं रखना है, मुझे मेरा काउंट 2 पे ही रखना है। बट प्रीवियस का क्या होगा? So if I put my count here or say current here, less than means, so it will not go if it is less than 3, right? It will not go. Okay, so it means that मुझे जाना नहीं ना, current dot next करना नहीं है। So कहीं ना कहीं पे मेरा I need to have one previous also, right? Previous होगा तो I have to delete it. What I'll just do is simply I'll put this condition. No? So how to delete it? Current Hmm. So as soon as my current reaches here or here, okay. So I will just do current dot next is equal to current dot next dot next. Yes, I'll do that. So current dot next is equal to current dot next. Okay. So my current this node is in the end I'll just return. What about my next node? Or I would say this. So after once I have here what I'll do is current dot next dot prev is equal to current. So and last node is equal to current dot next. So ln dot prev is equal to my current node. And then I'll return it. So current dot So I have taken my current is equal to my head. Okay. Should start from okay. So when my current is so I have moved my current to the node at position X. Now if this current is none, then I have to simply return the head. Or current dot prev is none. Is that current dot So simply I'll do current dot next, or I will say current dot prev dot next is equal to current dot next. If my current is here, let's say if my current is here, the same node which I have to delete, it means that I have to do Aris Khan, hello. So my current is here. So current dot prev will be this node. Current dot prev will be this node, and it's next, and it's next. Okay. So I have to come to this node, and its next means the address should be my this address, right? It means that current dot next, right? Okay. So my current dot prev dot next should be my current dot next, right? Yes. Okay. And so this will connect to the previous node, right? This will connect to the previous node, right? So previous node and next node will get connected. Okay. Now what I have to do? These two nodes are connected. Now I'll do current dot next dot prev. Okay. It means that now I'll do current dot next dot prev. Okay. So this current dot next dot prev, it should be equal to current dot prev. Okay. How? Okay. So current dot next dot prev. This is my current. Dot next means this. Its previous means this. Okay. Should be equal to current dot prev. Means this line. Okay. This green line I have to create. So this line I have created with the second um, command. And I'll simply say return head. There might be some if condition. Okay. So this connecting next to prev, right? What I'll write, connect next node to previous node. So I have to connect next node to previous node, and I have to connect previous node to next node, right? So what I have done is I have to connect next node to previous node, right? And I have to connect previous node to next node, right? So this direction and back direction, both I have to connect. Okay. Then only I would be able to completely delete this current variable. Okay. This is the main logic. Now there might be some error which we have to bug it. Okay, debug it. Okay. So let's try doing that. Okay. And at this point of time, if you need some help of LLM, or you need some help of any video, then now you can take it, because now you have actually understood the concept. You have understood the concept. The only thing is all those if and else statement where to put, and just basic logic you have to, that will come slowly and slowly, after you do some 10-15 questions completely only on doubly linked list. Okay, so that is the thing, right? Driver sheet or lead code, which one is high? Yukong Srivastav. Yeah, you can follow driver sheet. Uh, that is completely okay. But for interview style practice, you need to follow lead code, right? So after drivers, you can try some, let's say, uh, blind 75 question on lead code. That will be enough, I think. Start with drivers sheet if you are comfortable. Then you can go for lead code blind 75, because blind 75 is the series which is heavily asked in very good product based companies such as Google, Microsoft, and Uber, and all those good companies, right? So do once blind 75, and driver sheet is okay, you can go for it. Okay, so this was the concept which we have discussed. Now we have simply started with the while loop, and we have put this count as uh, x equals 3. Okay, so count should be less than x equals 3. Okay, you don't have to write this 3. Okay, only x, right? Then you have current is equal to current dot next and count plus equals 1. So count value का जो increase होगा, then it will again go to here and it will check whether the count is less than position or not. Okay. So in the end, when we come here, what do we have to do? We have to do some things. Like I told you earlier, we have to do certain things. We have to connect certain addresses. Okay, for this previous node and this next node, right? Let me erase it 0. Let me just erase all these things. Just erase it. Okay. So seven 93. Okay. So when my current has reached here, then what I have to do? I have to connect this. Okay, and I have to connect this. It means that current ka previous का next, करंट का प्रीवियस होगा ये दिस वन, राइट? उसका नेक्स्ट क्या होगा? उसका नेक्स्ट ये होगा, मतलब दिस एड्रेस आई हैव टू चेंज. उसका नेक्स्ट होगा करंट का नेक्स्ट. सो करंट का प्रीवियस डॉट नेक्स्ट इज इक्वल टू करंट डॉट नेक्स्ट. Okay, this is one condition. So my this arrow is completed. What about this arrow? Now what I have to do? Current का next का previous. Okay, current का next का previous. I have to update this address to this address, right? This one. Okay, I have to update this. So current का next का previous should be current का previous. So current का next का prev is equal to current का prev, right? It means that this address will have this address, right? That's how we will create both the arrows. Okay, backward, this forward arrow, and this backward arrow. Both arrow we have to modify so that we are able to remove this node completely. Okay, so it has these two addresses. All these two addresses should be removed, right, along with the value, right? So all these complete node has to be removed, right? So I have written the same thing. Current dot prev dot next is equal to current dot next. Current dot next dot prev is equal to current dot prev, right? Okay, now we will do return dot head. Now some things I have to write here. I have to put certain condition, right? Before going into putting these links, I have to check the current the current dot next status, whether the current dot next exists or not, right? If it doesn't exist, then it should not you know uh, run. It should not run, right? So I'll do if current dot next, where in the current dot next ka prev. Okay, so current dot next ka prev, I have to change that address if and only if my current dot next exists, right? Okay, so what I'm doing is, here you see current dot next ka prev, matlab this node. I'm checking this node ka value. I have to this address I have to change to this, but I should be aware that this node exists, right? So if current dot next, right, colon, so this means that this node works, right? This node will exist. Okay, so if this exists, then it will do current dot next. Current dot next, right? Okay, now let's try to compile. I have to do this. There's still some problem. Okay, I have to check the condition of previous node also, right? I have to think about previous node also. So initially, let's say I have here I'm I'm putting all these current is equal to current dot next, current is equal to self dot head, right? All this I have assumed, but uh, what if my x is invalid? Means x position is given that I have to delete this node. What if that x position is still invalid, right? Means that my current does not exist. Okay, or say my linked list does not exist. Okay, so what I'll do, let's say I have only head, or say I have only two letters. Okay, uh, not two letters. Let's say I have a linked list consists of only two elements. Okay, two nodes. Okay, and my x is 3, so x will be invalid, right? So that edge case also I have to take, right? So what I'll do is, let's take this edge case. If current is none, right, I'll just return my head means whatever nodes are given, whatever linked list is given, it will directly uh, you know give the head, give the complete list. Okay, still showing some error. Okay, what if my current dot prev is also none? So whatever is my current is the same as head, right? So okay, so let's say my current dot prev is none. How can it be none? Let's say my current dot prev. let's say I'm sitting at head, and here it is none. It means that my head will be current dot next. Current dot prev is none. Okay. Current dot prev is none. It means that current dot next is equal to head, right? It will become head. And if head is there, I mean, if we loop in through head, okay, then if head is the first, head is the only element or say node, then it means that my head ka previous will be none, and I'll simply say return head. So if head dot prev is equal to, it will be none, I'll just return head. I think if nested if is there, I'll just return head here. I don't know whether this is correct or not. Line 1. So write if x is equal to 1. Then I have to remove the head itself, right? So if current is not return head, then I'll delete the first node. Put some if condition, right? So here if current is none, we'll just return head. Because its position doesn't exist. So current is equal to my head. Count plus equals unknown. What is wrong with this? Continue return head. X equals head. Head. let us check the code in the LLM. So if current is none, I'll return head. I'll just delete head is equal to head dot next. If head okay. Is it? Head is equal to head dot next means move the head pointer. Head dot next is equal to head means okay. You should remove or comment out that line. Okay, so all the test cases are now passed. Okay, so this is the way how you can, all the edge cases you have taken. This is the edge case, this is the edge case, right? And this is the traversal. After that, this is again the edge case, and this is a very good question. Okay, I think in lead code is it given? Do you think the difficulty is easy? I don't think so. Average time is 40 minutes. People have taken 40 minutes to solve this question. We have also taken almost 1 hour 15 minutes, right? So let's search this lead code. Delete node in linked list. So you can see here this is medium level question. I want to delete a node. You will not be given access to the first node of the head. Okay, so this they have given. All the values of the linked list are unique and it is guaranteed that given node is not the last node in the linked list. So guys, let us do this question tomorrow. Okay, it will be a very good question, seems. Okay, so I think this question we can, it's solved. We can do this question tomorrow, right? Delete node. I think this is it singly linked list question? Topic. Let me check the topic. Topic is linked list. Okay. So there are 82 questions. Remove nth node from end of list. Merge to sorted list. Merge case sorted. This is for linked list, right? Okay, guys. So let's do this question tomorrow. Okay, and let's see where we are getting stuck and how we can resolve through it, right? So till then, bye bye and take care. See you tomorrow.